The SKLearn pipelines package makes it easy to manage multiple stages of feature transformation and modeling in a pipeline. So let me walk through how this works. In past iterations of the class, we actually used the pipelines in assignments but failed to teach it in lecture. And since it's a little bit confusing when you first see the prediction pipeline framework, I wanted to spend some time in this lecture actually walking through how to use it. We'll focus on a basic set of feature transformations. These are things like selecting a subset of columns, transforming those columns, and I'll also introduce the bag of words featurization that we described in the previous lecture as a stage in one of these pipelines. All right, so let's get started. So first I'm going to import the pipeline class and the column transformer class from the SKLearn pipeline and compose packages. The pipeline class is going to allow us to construct a pipeline, and the column transformer is a stage in one of those pipelines. So a pipeline is really just a list of stages, where those stages could be other transformations like a column transformer, and they can be models. And in fact, you can have pipelines which compose multiple models to make a final prediction. Again, in this video, we'll just focus on basic kinds of transformations and then a pipeline that terminates in a single model. In this case, we're focusing on linear regression models. So the first pipeline we'll build replicates what we did a moment ago, where we had a feature function that extracted just the cylinders and displacement. So the first stage in this pipeline is going to be this stage here. So a stage consists of a tuple, the name of that stage, and you can pick any name you like. I've called my first stage the select column stage, and then a transformation operator. And this is going to be some transformer or some model that will then be applied in that stage, producing some output, which will be then fed into the subsequent stage, both during training and during prediction. So in this case, the column transformer is going to be my first stage. The column transformer in this case actually takes itself a list of operations we want to apply. Each operation has a name which we get to pick, so I'm calling this the keep operation, and a function or name of an operation. So this could be some transformer, or it could be either pass through or drop. In the case of pass through, this stage is going to pass through the values of the cylinders and displacement columns. Okay, so this is a pipeline. It takes select columns, and I'm going to pull out the cylinders and displacement from the input data frame. And then the subsequent stage, the terminal stage of this pipeline, is to construct a linear regression model with that output. So pipeline behaves like a model. I'll come back to it in a moment. One thing that I can do once I've constructed this pipeline is I can pull a particular stage out by name. That's why we need to give each stage in the pipeline a name. So the select column stage returns the column transformer. If I had said instead linear model, I would get back the output, the linear model stage. Okay, so that's select columns. All right. Now, as I said a moment ago, this pipeline behaves like a model. In fact, I called it model. And so I can say fit. So in this case, I'm going to fit that model, and that's going to fit each of the stages. You can think of it as essentially invoking fit on each stage in the pipeline. A transformation does nothing when fit because it's just a basic transformation in this case. In a future video on this same notebook, we'll actually deal with a transformation where we do some interesting computation. In particular, we're going to need to identify the words in the vocabulary for a bag of words transformation that will actually do something during the fit stage. But again, here we're just fit on the select columns is doing nothing. It's just going to return the cylinders and displacement. But then the fit on the linear regression stage takes the output of the fit model on the previous stage and is going to, in fact, fit a linear regression model. Okay, so we fit it. So that fit all the stages of the pipeline, just as I described. And just as before, we can now use this entire pipeline to make a prediction. Notice here that I no longer need to apply the feature function to my training input. That is now part of the model itself. So we make a prediction here. I'm going to get 4.589, which is what we got before. But now that feature function is built into the model. So I don't have to keep track of it. And as before, when I apply to the test data, I don't have to apply the feature function again. The same feature function is now going to be applied to the test data. Now, you should not be testing the model on the test data at this point. But again, I'm just showing you how it works. All right, so because I want to make some plots later about how all the models perform, I can now put this model I just constructed into a dictionary, which I'll call models. And I named it columns plus displacement, or the C plus D model, as my first model. Now, you might actually want to do more interesting transformations. And so I just added this additional stage to this notebook. When I first released the notebook, it didn't have this additional transformation. Now, suppose I actually wanted to look at maybe the volume of displacement per cylinder. So I have an 8-cylinder engine with the large displacement. But what's the displacement per cylinder? Because that might translate in some way to efficiency as well. So I can define a new transformation function. To do that, I need to import the function transformer. So this is going to wrap just a vanilla Python function into a transformer, which has a fit, but it'll just skip the fit stage and use the same thing for predict. So remember, each stage of the pipeline technically needs to have a fit and a predict to be a stage of the pipeline. But here the fit is a no-op and the predict just applies the transformation. So I'm going to construct a function transformer, and it's going to use the compute volume function. The prediction, or the operation this will do, is it's going to take the two columns it's given and the ratio of the second column over the first. So now it's up to me to make sure my columns make sense when I pass them into this. So now I'm going back to my pipeline. I'm going to build yet another pipeline. In my select column stage, I'm actually going to apply two different column transformations. The first is before is going to keep, just going to pass through the cylinders and displacement. And the second transformation is going to construct the per cylinder volume. It's going to take the volume transformer I just constructed up here. This is the volume transformer. And it's going to apply that to the columns cylinder and displacement again. And so the column transformer will look up these columns and feed their values in as a matrix to the volume transformer function, which will then construct this ratio that I've requested here, which will be the ratio of displacement divided by cylinders, because the second column here is displacement and the first column is cylinders. Got it. Very good. All right, so then I will pass this to the output of this stage will then be fed to my linear model, which will do regression. We'll learn a regression model for that output. So let's just do a quick recap. So how many columns will I have? Well, I have a cylinders column and displacement columns, which I chose to pass through. And then I will take cylinders and displacement and apply the volume transformation to those columns and pass all three of those columns into the linear model. Note the linear model by default will actually add an intercept term. So it'll add an additional ones, essentially a ones column to my linear model. All right, so let's run this. So we construct our transformation, construct our new pipeline, now much larger, and we go to fit it. And you see we fit all the stages of our pipeline. It again got a bit larger. We can now make a prediction. What was our prediction before? On our training data set, it was 4.589 was our error. Let's see what we've got here. 4.31. So we did reduce the error in miles per gallon, a reasonable amount. And we'll again save this model to our dictionary. So now I've constructed two models, one which is just C, the columns plus displacement. And now we have a model which is the displacement divided by columns. I apologize, the plus notation is a bit confusing here. This is just including the columns and displacement, and then this is actually a mathematical operation, displacement divided by number of columns. Bad model names, pick better names when you do this on your own in the future. Now, one thing we might want to do is keep all of the quantitative features. So we can get the cylinders, displacement, horsepower, weight, acceleration. Let's go back up to our data frame really quickly. Scrolling way back up. All right, so here's an example data frame. So these are all cylinders, displacement, horsepower, weight, acceleration. I think I didn't include model year, but we could. All of these are numeric quantities that would predict miles per gallon. So we could try to include them all. Let's go back down. So where were we? Right, so cylinders, displacement, horsepower, weight, acceleration. I didn't include model year. We could have done that as well. So I'm going to take all of these. So I am going to keep all my quantitative features, and as before, I'll keep my cylinder volume, my additional feature transformation. And so this is going to be my new model. Let's go ahead and try to fit this. So I try to fit it. I knew in advance it's going to generate an error. So it did, in fact, generate an error. Input contains nan, infinite. We have an infinity or a value too large for D type. All right, so what's going on? Probably I have a missing value. So let's go back again, take a look at our data at the very beginning. All right. Maybe look at our training data. Do we see any nans here? Let me scroll around. Any nans? Any not in numbers? Oh, okay, there's a nan. So the horsepower column might have a missing value. That's at least one missing value we've seen. If we try to feed a missing value into the regression model, it doesn't know how to deal with it. So let's go back down here. Where were we? Sorry about scrolling so quickly. It's bad YouTube form. Very good. So yeah, so we tried to fit a model when we had missing values. We can actually address this by adding an additional stage to our pipeline. So I'm going to add an imputation stage, which is going to impute a value for the missing value, so I can go ahead and feed that data into the linear regression model. An alternative design could be to drop the rows with missing values. We could add that as a stage as well. But for our purposes here, I'm actually going to show you how to add imputation. So the simple imputer here is an additional stage that I'm going to apply after selecting the columns that I wanted. So the simple imputer, I believe, constructs the mean. Let's go ahead and try to run this. So we'll run this cell here. So the simple imputer, I believe, tries to construct the mean. Missing values, the strategy here is by default mean. We can try different strategies. I'm not going to do that here, but you're welcome to try this on your own. So going to add an imputation stage, which will fill in missing values in columns, and it'll construct the mean for the column based on the training data, or whenever we call the fit. And then it'll use that same mean when imputing on any new data set, for example, at test time. So now this imputation stage will actually do something during the fit stage that's distinct from when it goes to make a prediction. All right, so we'll fit this to our model, or to our data, our training data. Now our pipeline's getting a bit longer. And we'll go ahead and save this model as well. And now we can evaluate this. And we see that we were able to further reduce the training error. Now, we're really starting to wonder, what's the test error looking like? Are we starting to overfit? Maybe, maybe not. We shouldn't look at the test data set. Instead, we should use cross-validation to evaluate our model. And so in the next video, I'll walk through how we use cross-validation to compare these different models.